Okay, we're on page 5. 12.3. All right, so now that you're kind of familiar with matrix, we're going to talk about a few more functions of matrix. First, we're going to do identity matrix. The identity matrix is a diagonal matrix. And diagonal and also a square matrix. That means both rows and columns have the same size. So I2, when you see I2, it means identity matrix 2 by 2. So first, it's going to be a 2 by 2. And the way diagonal matrix look like, or identity matrix looks like, is that it starts with 1 on the top left corner, and then the whole diagonal is 1. And then everything else is a 0. Okay, the whole diagonal is 1, everything else is a 0. The diagonal has to go from the top left to the bottom right. So that's how the diagonals go. So for example, I3. I3 is going to be a 3 by 3 matrix and goes 1, 0, 0, 0, 1, 0, 0, 0, 1. So 1s go down the diagonal, everything else is a 0. So what size would I4 be? 4 by 4? All right, go ahead and draw out or write out all the elements for I4. Okay, so I4 is going to look like 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. Okay, easy step. Now you need to remember how it looks like because eventually we need to do something to matrix to make it look like that. So you got to remember that is the final goal for some of it. Okay, now let's talk about multiplicative inverse for matrices. If we're going to just talk about multiplicative inverse for numbers, we're talking about like 5 times what is 1. So 5 times what is 1? 1/5, right? So the relationship between 5 and 1/5 is that they are multiplicative inverse. So now we're going to apply the same logic to matrices. So if A and B are square matrices and A times B is equal to I being the identity matrix, then we're going to say that A and B are inverses of each other. Inverses. So if A times B is going to give you the identity matrix, then A and B are inverse of each other. Okay, A and B are inverse of each other. Now, when we write inverse, so basically B is the inverse of A, and we don't usually write B. So if we want to specifically say that B is an inverse, we would say that B is basically A with a -1 on top. That -1 on top does not mean, so this -1 is not the same as this, okay? Unfortunately, in the math world, that -1 has 2 meanings. One is the exponent stuff, you flip it down. The second means inverse, and in this case, it means inverse and not a reciprocal. Okay? Sometimes it means reciprocal, sometimes it means inverse. In this case, inverse. Okay? So A inverse. All right, very important because when we get to the next 2 chapters, this is going to come up a lot, and I hope you don't make a mistake in thinking that is reciprocal. All right, check whether the matrices are inverse of each other. How are you going to check to see if they're inverse of each other? So is A and B inverse of each other? How are we going to check? Yes, multiply them, and then what are you supposed to get if they are inverse of each other? Identity matrix. So if A and B are inverse of each other, then when you multiply them together, you should get I. Okay? All right, so let's try multiplying them. A is 1, 2, 3, 4. B is -2, 1, 3/2, -1/2. So we're going to multiply them together and see if we actually get the identity matrix. Okay, go ahead and try that. See if you get 1, 0, 0, 1. All right, when you do this, if you did it correctly, you should get 1, 0, 0, 1. So that means they are inverse of each other. Okay, go ahead and try the second one. The second one doesn't have fractions, it's a little bit easier. So you're going to again check, is A, B inverse of each other? To do that, you multiply them together, and you're looking for the identity matrix. All right, A, B are not inverse of each other, but please be careful with your multiplication, because a lot of you, obviously it's not going to give you 1, 0, 0, 1. However, your multiplication, some of the elements are wrong. Please be careful. It's 0, negative 2, 2, 4. Okay, so if you're not getting those exact numbers, please be careful with your multiplication, and you may want to just use the calculator. Okay, next. Determinant. So there is a special thing about the matrix, that there is a special number. So if you have a matrix that is A, B, C, D, like that, and they said that they want to figure out the determinant of this matrix, so you got to remember this word, determinant. When they say they want the determinant of this matrix, they sometimes will write it like this, DET matrix. So that means they want the determinant. Or they put this thing that looks like an absolute value that tells you, I want the determinant. So for example, this one, they want the determinant. Now, how do you find the determinant? Okay, so what you're going to do is, first of all, do you guys know Breast Cancer Awareness Month? Yeah, I think that is October. And do you know what the symbol is for breast cancer awareness? It's like a ribbon, right? It's a pink ribbon like this. Yeah? So we're going to do the same thing, except we're going to do this opposite. So it's a reverse breast cancer awareness ribbon. So we're going to start from A, and then we're going to draw a line down to D. And then we're going to loop around to C, and then go up to B. So it's like a upside down ribbon. Okay, start from A, goes down to D, go around to C, and then back to B. Okay, the way we actually do this mathematically is AD comes first, so then A times D is what you're going to do first. When you go around, that means a minus sign, and then when you go up, you multiply C and B. So the determinant is AD minus CB. AD minus CB. So you start from the top left, go down, so multiply, minus, multiply. Okay, so let's try one. Find the determinant of this matrix. 3 times 5 minus 2 times negative 1. Okay, so that's going to be 15 plus 2, which is 17. Okay, top left to bottom right, minus bottom left, top right. Good? All right, let's have you guys practice A and B. Okay, the answers are 3 and 0. Okay, so 2 by 2 matrix is very easy to find the determinant. We're now going to do 3 by 3 matrix. This is going to be a little bit harder, but I'm pretty sure you guys can do it. All right, 3 by 3. Please be super careful with your multiplication, because if you're making mistakes, when we were doing the 2 by 2 matrix multiplication, then this is going to be a lot of numbers. So please, no careless mistakes. All right, find the determinant of this 3 by 3 matrix. What you're going to do, so I have some steps written out here for you. First, you're going to rewrite the first 2 columns of the matrix to the right of the determinant. Rewrite the first 2 columns of the matrix to the right of the determinant. Okay, so what we're going to do is take these first 2, and then we're going to rewrite it on the right. 100,435. So that's the first step. Take the first two columns and then rewrite it. Take the first two columns and rewrite it. Okay, step two. Step two is you're going to draw 3 diagonals down towards the right. Okay, we're going to draw 3 diagonals down towards the right. 3 diagonals down towards the right. Okay, we're going to draw 3 diagonals down towards the right. If you're doing it on an iPad, obviously you're going to draw the diagonals. But for if you're going to do it on paper, don't draw anything. Just mentally know you're going down the diagonal. And then what you're going to do is you're going to multiply the 3 elements together and write the product at the end of the diagonal. Okay, so let's look at this diagonal. So first, let's look at the diagonal that says 1, 4, 2. So you're going to multiply all the numbers 1 times 4 times 2, which is 8, and then you write it on the bottom. Okay, you do the same thing with the other one. Please be careful, 0 times everything is 0, so this one you should just say is 0. I know sometimes when we're doing multiply, we accidentally do adding in our head, so then you might end up with like a -3 or even 2 or something like that. Please be careful, it's just 0. And the same thing on the next one. -2 times 0 times 5 is 0. All right? Okay, so that's step 2. Draw the 3 diagonals and then multiply all the way down the 3 diagonals. Next, draw 3 diagonals upward towards the right. And then you're also going to multiply the 3 elements together. Let me give you a second to quickly write this down. Okay, step 3, you're going to draw the 3 diagonals upward towards the right, and you're going to also multiply the elements together. Now, where do you draw these diagonals? You're going to start from the bottom left up. 1, 2, 3. And then you're also going to multiply them together. So in this first diagonal, 3, 4, -2. So multiply them together. 3 times 4 is 12. 12 times -2 is -24. So -24 goes up here. Okay, and then do the same thing with the other 2 diagonals. So 5 times -1 is -5 times 1 is -5. So that goes up there. And the next one has a bunch of zeros, so that's just 0. The last thing you're going to do is the one that's actually going to help you find a determinant. You're going to add the bottom product and subtract the top product. So I'm not sure how you want to do it so that you keep your signs clear. Okay, add the bottom, subtract the top. Add the bottom, subtract the top. So you're going to go back here. So a plus 0 minus all the stuff on the top. So I don't know how you want to do it. You can subtract it as you go, so kind of mentally change the sign, or you can group them together and then subtract them later. Not sure how you want to do it, but you need to subtract all the numbers on the top. Does that make sense? I'm going to leave it up to you guys to decide what you want to do, but just keep it consistent. The worst thing that you can do in this, this is all super easy math, right? You're just multiplying and adding. It's very easy to make sign mistakes, so please be careful. Okay, this is 8 minus 29, so that is 37. Right, unless I did something wrong. That's right? Okay. Good? All right. Okay, so as you can see, this is not very hard. It's just trying to memorize all those steps and don't make mistakes. So let's have you try one. This one. Okay, let me know when you have the determinant. The determinant is negative 48. Okay, if you didn't get negative 48, you got some other numbers and you're not sure what happened, you can ask me, I'll check it for you. Okay, the last thing we're going to do today is basically we're going to use these determinants somewhere. We're not just looking for them for fun. And that is inverse matrix. So we talked about inverse matrix already. We said if you have a matrix times its inverse, you should get the identity. Now we are going to not use that way to find the inverse. We're going to find the inverse matrix immediately. Okay, so if an inverse of a matrix exists, meaning if you can inverse that or invert that matrix, then, grammar error, its determinant has to be non-zero. Okay, what does that mean? If you have a matrix and you want to figure out, does this matrix have an inverse? Then you check the determinant. If the determinant is not zero, then it has an inverse. If the determinant is zero, then no inverse. Okay, so if a matrix has no inverse, so has a determinant, yes, inverse. No determinant, like it's zero, then no inverse. If a matrix has no inverse, we have a special name for that. We call that singular. So if it has no inverse, you cannot invert it. We call that singular. All right, so let's take a look. If A is A, B, C, D, what is A inverse? Okay, so we need a formula for A inverse. First, we need to find the determinant. Okay, so the formula is 1 over determinant. Okay, so determinant, we found it before. And then this is the crazy part. Okay, we're still going to do the reverse breast cancer awareness sign, but it's a little bit different. We're still going to go this way, A, D, C, B, but we're going to switch A and D. So we're going to switch the positions. So then it goes D, A. Okay, so we're still going to go down in that order, but this means different thing this time. So we're going to switch A and D, and then the other two, we're going to make them negative. But we don't switch them. We just make them negative. Okay, switch A and D, make C and B negative. If you multiply all that together, that gives you the inverse matrix. Okay, so let's try this one. Does A have an inverse matrix? What do we have to check to see if it has an inverse? Yeah, determinant. What are we looking for? 0. So if it has a 0, what does that mean? Yeah, it does not have an inverse. Okay, so all we care about is the determinant of A, 0? We want to know what is the determinant. Okay, so let's have you really quickly find the determinant. What is the determinant of A? What is the determinant of A? What's the determinant of A? Negative 3, yep. So does it have an inverse? Yes. If the number is not 0, it has an inverse. Okay, if the number is not 0, it has an inverse. So there is an inverse matrix to this, so then we want to figure out the inverse matrix. Okay, so let's follow the formula. The formula is 1 over determinant. So 1 over determinant, which is negative 3. And then we're going to multiply by the matrix. The matrix says we are going to switch A and D. So we're going to switch A and D. Okay, switch A and D. And then make BC negative. All right. 1 over -3 is what kind of number in the matrix world? What do we call that? Yes. Say it a little louder.
Was it scalar?
Yes, scalar. So this is a scalar. So we're multiplying a scalar to a matrix, which is okay to do. So we're going to multiply that in. -1, 2, -1/3, 1. All right. So this is the inverse matrix. Yeah.
You do the switching C and D on the original one, right? Like,
Correct.
Okay.
On the original one, yes. Yes. Now, how do you check to see if you got the correct inverse matrix? Do it again? No. How do you check to see if you got the correct inverse matrix?
Multiply A by the answer.
Yes, and what are you trying to get?
The one on the diagonal.
Yeah, identity matrix. So, how do you know if you got the correct answer? Multiply A and A inverse together. If you get 1, 0, 0, 1, then you're good. Unless you, huh? No, you don't have to do that. It's just kind of showing you, like, sometimes people are like, did I get the right answer? Then I'm going to give you another way to check. All right, we have a few more minutes. Okay, find this. Does it have an inverse? If so, what is A inverse? All right, A does have an inverse, and then A inverse is equal to 1, -1, -3 halves 2.